Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another lead code problem, that is 3 sum. It's a medium level question and it's a very popular question, as you can see from the likes. So we are given with an integer array nums and we have to return all the triplets, right? Triplets in the sense nums I, nums j and nums k, such that I not equal to j, I not equal to k and j not equal to k. Means all the three are not same. They have a different, they are all different elements from the integer array. And we have to return the triplet such that nums I plus nums j plus nums k equal to 0. So that the sum of all the three elements or the numbers is 0. Also we that the solution set must not contain any duplicate triplets, right? So let's see an example to understand this problem. So we are given with an integer array like -1 0 1 2 -1 -4. As you can see, -1 -2 -1 -1 and 2. So sum of all these three numbers will be 0. Similarly, the sum of these three elements, right, or the sum of this triplet will also be 0, right? -1 becomes -2 and +2 downs to 0. -1 plus 0 is equal to -1 and +1 downs to 0 again. So these are the two triplets which satisfy the condition. So let's see how we can solve this problem, the idea or the intuition behind solving this problem. For the triplet, like x plus y plus z, let's consider x plus y plus z, x y z, the triplets, the elements of the triplets, and we have to find the sum as 0, right? We have to find three elements from the array forming a triplet that is equal to 0. So suppose if we break down this into two things, right, where we keep x as it is and the other two elements from the array, that is y plus z, for a new target, that is t dash, right? So that 0 is a target t, right? So we have divided into two parts here. We are keeping the first element of the triplet x as it is, right, and saying that we have to find now, instead of 3, 2 elements from the array, but for a target t dash, right? And t dash is a t minus x, and t dash is a target which is equal to t minus x, right? So instead of finding 3 elements, we have broken down into a smaller sub problem where we will finding 2 elements, right, with a target t dash, right? And finally, if we are able to find y plus z, which is t dash, so we will be able which will be equal to t minus x, and then finally if I will add x plus y plus z, bringing x here, it will be equal to the target t, that is 0, right? So that is the intuition, or that is the idea we will be following. So let's see with an example the approach or the idea that we discussed. It will be more clear when we dry run. So before starting the intuition or the idea, we have to sort the elements as well. So the array needs to be sorted, so it will be sorted in increasing order, right? -4 -1 -1 0 1 2, right? So now what we will do is we will take this element, that is -4, as our x, right? The first element, that is -4, and the new target. So as we know, the target is 0 and the t dash will be 0 minus x, right? So 0 minus of minus 4, that is 4. So the t dash is 4 for the 2 sum. We have our t dash, right? And now we have to perform the 2 sum for this target. So we have to find two elements y and z for which the sum is 4, right? For which the sum is 4, right? So what we will do is we will initialize the left. So we will initialize the left and the right as the leftmost and the rightmost element, right, of the array. Now we will do left plus right. So left plus right is -1 plus 2, that is 1, which is smaller than 4, right, which is smaller than the target t dash. So we'll increment our left. So left will be again -1. We'll increment our left, but the new the left pointer is again pointing to -1, which is same as the previous. So whenever we have a element again which is same as the previous, will not perform anything, will skip. So skip and do left plus plus l plus plus. So now again the left will be pointing to 0. So the left plus right again will do. So it will be 0 plus 2, right, that is 2, that is still less than 4, right? So we will again increment the left. The left is pointing to 1. So again left plus right, that is 1 plus 2, that is 3, is still less than 4. So we have to again increment our left. So left will be pointing to 2, but we'll break here. Now we will break because we have to run only while left is smaller than right, because we want distinct elements whose sum is going to be 4, right? We have to take the distinct triplets, right? So the list is empty. There is no elements, no set of elements, no set of y plus z. There is no duplets, you can say. There are no duplets whose sum is 4. So the list is empty. Now for -4, because as the list is empty, for -4 there is no triplet, there will be no triplet. Now we will increment our I to the next element, that is -1. So for -1, so now the x is -1 and our t dash will be 0 minus of -1, that is 1, right? And we have to take the elements from I plus 1. So I is pointing to -1, so the elements will be -1 0 1 2. What we will do now the target is 1, right? So target is 1. We have to find duplets from the 2 sum, doing 2 sum. So again we will start from the left as -1 and right as the rightmost element and the leftmost element. So we'll do left il plus r, that is -1 plus 2, that is 1. So is equal to 1, that is target. So we'll add -1 2 into the list and we will increment left. The left will point to this and decrement right, so right will point to 0 1. Again we'll do left plus r, that is 0 plus 1. So again it's equal to 1, right? Is equal to 1. So we'll again add 0 comma 1 in the list, right? Now we will again increment l and r. So now r has become smaller than l, so we'll break and we'll return these two elements, that is -1 2 and 0 comma 1. So now in the threesome what would happen, we will add -1 comma -1 2 as a first list and -1 0 comma 1 as a second list to make it a triplet, right? So these are the two triplets whose sum is 0 now. Now again we'll increment I. So now this is same as the previous -1, so we'll skip it. Now we'll again increment, that is 0, right? So the now new element is 0, right? So x is 0 for us, and what is the target? T dash. T dash is 0 minus 0, that is 0. Now we have to find duplets from the two sum with target as 0. The arrays that we have to take, we have to do two sum on is I from I plus 1 till n, so it will be 1 comma 2. So this will be the area for the two sum now. So again we will start our left and right from 1 comma 2. So L plus R is equal to 3, which is greater than 0. So we'll decrement R. So now R will become equal to L, so we'll break, right? So for 0 there is, so for target 0 we don't have any duplets. So ultimately there will be no triplets for 0, right? Starting with 0. Now we will increment 1, right? So the new element would be 1, right? So x will be 1 and the target T dash will be 0 minus 1, that is -1. From the elements 2 only, because we have to take the arrays from I plus 1. So as you can clearly see that the sum is the two, there is no enough elements for the duplets, so we'll return empty and there will be no triplets for the two. So the only possible triplets are -1 -1 2 and -1 0 comma 1. So let's see the code part for it. So we have our result equal to new array list that we will return as a list of list. So we have sorted the elements. So for loop we have started from 0 and we'll do till length -2, right? Because for the triplet at least we need 3 elements, and if I is not equal to 0, right, if it is not the first element, and nums of I is equal to nums of I minus 1, if the new element is same as the previous one, will continue with it. Now we will store the element nums I into the temp and we'll find a target, that is T dash, on which we will perform the two sum. So we'll subtract 0 minus nums I, that will be our new target, and we'll pass this target in the two sum, and we will do I plus 1, because the new range of arrays where we have to perform two sum will be from the I plus 1 till the till n, the length of the array, right? So in the two, let's see the two sum. So in the two sum we again have a list as a result array. We initialize our left from the ith pointer, right, that we passed from the 3 sum, and right will be the last that will be the array length -1, right, the last element of the array. So we'll do the two sum till left is smaller than right. So if again we'll check if I is left is not equal to I, it means that it's not the first element, right, of the array. And if this array dot left is equal to array dot left -1, means it's same as the previous one, so we'll skip, we'll not do anything, and we'll do just left plus. We'll skip and proceed further. If the array dot left plus array dot right equal to target, means we have found a duplet, right? If we have found a duplet, so what we will do, we'll add the left element and the right element in the list, and we'll add that list into the resultant list, and we'll do right minus, we'll decrement the right pointer and increment the left pointer. Else if array of left plus array of right is greater than target, then we'll decrement the right pointer, else we'll increment the left pointer, and finally we'll return the result list that it is formed. So now when we return the result list from the two sum, what we will do for each list from the two sum, from for each list that we got from the two sum, we'll add the first element num psi that we kept in the temp. So we'll add the temp and then the list into the resultant, and then finally we'll pass the result. So let's run this program. So yes, test cases are accepted. So uh, the solution is working fine. So let's see the time complexity for this. So as you can see, we are running two for loops, one for the threesome, that is running for almost or big of n times, and inside for each element we are running another loop, right, till left equal to 1, that is performing the two sum for two sum, right. So it will be order of n square time complexity. So the total time complexity will be big O of n square. I hope you like this video, and if you like this video, please share and subscribe. It will keep me motivated to bring more such videos. Thank you.